Okay, so hello everybody. I'm Han-Chen Li. I'm a postdoc at the University of Geneva. So today I'm going to present our recent studies about the polarization measurement of the Crab Pulsar with polar data detector. And so my talk is divided into 5 parts. I will start with the introduction of polar detector, and then I will introduce some poster studies with polar. And finally, our summary and outlook will be given. So for the first part, I think Marnie's talk already covered a lot, so I will skip all these details, but I just want to remind one thing, which is that Polar is a wide field of view detector that working in a scanning mode. So it is dedicated for transient sources, therefore for persistent sources like the Crab Pulsar. It suffers from a high background level and complicated observational parameters. And at first, for each photon observed by Polar, we corrected its time of arrival with respect to the source position and the solar system barycenter clock. And then we tried to search the periodic parameters and to get folded pulsation. So this middle left plot shows you the way of phase folding to obtain pulsation from noisy data. So then based on the intensity of no impulses in our sensitive energy band, we tried to search signals of low impulses in order from numerals to faint. And for the moment, we have 2 confirmed pulsars, which are the Crab Pulsar and the B150958. And the top table, the top right table shows you the best fitted periodic parameters, and the bottom plots are pose profiles of them. And as you can see, the detection of the Crab Pulsar is much more significant than the B Pulsar. So for now, we just focused on the Crab Pulsar to do further studies. So we played a little bit with the measurement of the crab. So the pulsation as a function of time was plotted on the top left. So we use X-ray phase 0 as a reference. And so you can see these peaks aligned perfectly with time. Then to be sure about our timing model, we used the joint observation data of Polar and Fermi to search the best periodic parameter. As you can see on the bottom left, the periodic parameters are in agree with Fermi's. So this shows our timing model is reliable. And we also show the pulsation as a function of instant angle, the theta, where we can clearly know the visibility of the Crab Pulsar could reach up to 100 degrees. And then the pulsation as a function of 1,600 centimeter bars were also shown. So every bar has a good detection of the Crab Pulsar. We could confidently use this location information to extract modulation curves. But before we do that, we furtherly extract the spectrum of the crab. By fitting with the detector responses, we got the phase resolved spectroscopy of the Crab Pulsar. So these read points are from Polar, and they are comparable with other instruments in a similar energy band. And this work could serve as a calibration of the Polar detector. Then we could move on to the polarization. But at first, we can look at this. So normally for GRB, we could do we could use the time information. We define the background interval and source interval. Then we can subtract backgrounds, and we fit the net source modulation curve with responses. And as for the crab, we could also use a phase interval to do that. We have our background interval, which contains the background and the nebula contribution. But for the crab, the analysis is complicated by 2 additional parameters, which are instant directions and the rotation of the source. So we have to deal with multiple data sets. Here today, I have to skip some technical details, but we found a way to solve all these issues, and we managed to get the polarization results. So our results shown here, we do 3 phase intervals. You can find their definition on the top left. And from the delta chi-square maps on the right gives us the best fitted value of polarization degree and polarization angle. You can find it on the minimum chi-square value from these points. And these values are also listed on the left table. But I didn't show the errors now, since we are also doing our Bayes approach, where we can get our post-error, then we will get these errors formally. So this work will soon be published after Bayesian analysis is done. But overall, our results are consistent with other measurements like the Pogo Plus. So here let's have a quick look on the comparison. So the left plot shows the recent polarization measurement on the averaged phase of the Crab Pulsar at high energy band. So from the bottom panel, we see the polarization angle quite agree with each other at different energy bands. But for the polarization degree, there are some puzzles, such as if you look at this these points, is the polarization degree increase as a function of energy? So we cannot answer these questions based on the current observation. And since some of these measurements suffered from unknown systematic effects because of no polarization calibration on ground, so there are some doubts on some of these results. But anyway, our high precision measurements and our energy resolved measurements are needed to clarify some of these issues. And additionally, if you look at these points, we see there is no measurement at around 10 keV. So all of these motivate us to do something with Polar 2. So Polar 2 has a lot of advantages than Polar. Martin already introduced about that. So in a word, it will obtain observation of the Crab Pulsar with much higher signal to noise ratio. Then based on the Polar's observation and we do some Monte Carlo simulation of the Polar 2, we try to predict the polarization measurement of the Crab Pulsar by Polar 2 for about 2 years observation. And we also put Polar there to compare. So the left plots are for Polar and the right ones are for Polar 2. And from top to bottom are unpolarized and 10% and 20% polarized input to the Monte Carlo simulation. Well, if you look at the non-polarized inputs, Polar 2 has more stringent upper limits. And for modest inputs, it could give much more significant detection. So these enhancements allow us to do a finer phase resolved polarimetry. We can define the phase range much smaller, and we can try even energy resolved polarimetry. Then we can offer more clues for theoretical model. And benefit from that, we could hopefully do a few more pulsars and even some solar flares, even they are very soft. So let me summarize my talk. So as a wide field of view competent polarimeter, Polar has joined in pulsar studies. We could do phase resolved spectroscopy and phase resolved polarimetry of the Crab Pulsar. And we expect that Polar 2 will do this work much better than Polar. So I will stop here. Thanks for listening.